In this lecture, I will talk about an architecture of a Kubernetes. So let's start. So here you can see in the figure, I have defined one master server and few worker nodes. So you can have two master and two worker node, or one master or three or four worker nodes. So it is up to you how you are designing. So it looks like a server client architecture. For our lab purpose, I am going to use one master and two worker node. And here inside this master node, we have few components like your scheduler, API server, etcd database, and controller manager. And for this worker node, we need to understand few components like kubelet, service proxy, or we can say it's a kube proxy, container engine. So here you can use any software for the creation of containers. It could be Docker, Rocket, and Containerd. But for our lab purpose, I am going to use the Docker. So here the benefit of Kubernetes, it supports any software which is going to create the containers. If I will talk about Docker Swarm, so Docker Swarm only supports Docker. But here Kubernetes supports n number of softwares who is creating the containers. And also we need to understand about the pod. Pod is your smallest unit of the Kubernetes, or we can say it's a logical boundary. And inside the pod, we have the collection of containers. Your Kubernetes always talk to the pod. Your Kubernetes never talks directly to the container. So here you have to keep in mind. I will come to that point later. First, we need to understand about the components. Now let me take an example so that I can easily tell you how these components works all together. Suppose I want to create two Ubuntu machine as a container. So what will happen here for the creation of containers, I am going to use the kubectl command. We'll understand about this command in the upcoming lectures. Just for understanding about these components, I have taken an example that with the help of kubectl command, I am going to create two containers. And those containers is nothing, they are just a Ubuntu machine. So kubectl is the command line configuration tool for Kubernetes that communicates with the Kubernetes API server. Here the request first will come to the API server. So API server is the front end of the Kubernetes control node, or we can say the master node. So if there is any request, it will always first come to the API server. Or in simple words, we can say API server is the entrance gate for the Kubernetes cluster. If any components, if they want to communicate to each other, they have to go via the API server only. So here API server is how the users interact with their Kubernetes clusters. The API server determines if a request is valid and then process it. So here the API is the interface used to manage, create and configure Kubernetes cluster. It's how the users and external components and parts of your cluster all communicate with each other. So I believe you understood what is API server. So as of now, just keep in mind that if you want to communicate, if anyone wants to communicate with your Kubernetes cluster, the only way is via the API server. Now my request for the creation of two Ubuntu container has reached to the API server. Now coming to other components. Here we have this controller manager. So controller manager will make sure that the request should be completed successfully. If there is a request that hits to your API server, that request will be taken care by your controller manager. Controller manager will come to know that, okay, there is a request for the creation of two Ubuntu machine. So what it will do here, it will communicate with the etc database via the API server. Here the controller manager cannot directly talk to the etcd database. It has to go via the API server. So what this controller manager will do here, it will cross check in the database. In the etc database, it keeps the information about the entire cluster, like what all the components that we have in this cluster, what all the pods we have, what all the kubelets, service proxy, Docker inside the pod, what all the containers are running, how many resources has been allocated to which pod, and what is the IP address that has been assigned to pod. So each and everything information is stored in this database. Your controller manager will cross check that where we can create these two Ubuntu machines. After consulting with this database, your controller manager will come to know that this particular request or this particular Ubuntu image or Ubuntu container can be created on a particular node. So here you can see we have 3 nodes, node 1, node 2 and node 3. And here your controller manager is going to consult with the scheduler, because the responsibility of a controller manager is to manage, is to make sure this particular request should be completed. But who is going to complete this request? Your scheduler. Your controller manager will instruct to the scheduler via the API server that you can create these 2 Ubuntu images or Ubuntu container on this particular node, and you just go and create the pod and then create these images. So what will happen here? Your scheduler will go to the node via the API server. Then it will go to the node and then it will talk to the kubelet. Your kubelet is going to create the containers. So here kubelet is nothing, it's a node agent that runs on each node. Suppose you have 3 nodes, so it means 3 node agent is running on each node. So your scheduler is responsible for the creation of images, or we can say the container of Ubuntu machine. So it will come to the node 1 and it will hit to the kubelet. Your kubelet is a node agent, and it is first going to create the pod. Suppose they want to create 2 Ubuntu container, so maybe it is going to create 2 pod, and inside the pod it is going to create containers of each Ubuntu machine. So this is going to be decided by your Kubernetes architecture only. All the components will talk to each other and will come to know that how the pods would be created, whether it requires 2 pod or 1 pod. So it is not our responsibility, it's the Kubernetes responsibility. Suppose they have created 2 pods. After that, they have to create the containers, because we have to create the Ubuntu container. We want to create Ubuntu machine as a container. So for our lab purpose, I am going to use the Docker. Then it is going to consult with the Docker, and then Docker is going to create the container inside the pod. So it is going to create 2 pod, and each container is going to run on each pod. And your Docker is going to create the container of the Docker image. And one more thing here, that your service proxy or your kube proxy is responsible to allocate an IP address to the pod. So your network related things can be done by your kube proxy or service proxy. The containers will not get an IP address. Your pod will get an IP address. Container will not have any IP address. So here you have to keep in mind that. And network related things will be controlled by your service proxy or kube proxy. So I believe with this example, you can easily correlate how the components of a Kubernetes cluster works together, and how the things happen inside the cluster. No worries, in the upcoming lectures when I will be going to create the cluster, then you can easily understand all these components. I will show you each and everything. So friend, that's all. We'll see you in the next lecture.